A fascinating breakthrough has emerged from the James Webb Space Telescope (JWST), which recently identified potential biosignatures in space. These chemical signals were detected approximately 4.24 light-years or around 25 trillion miles from Earth, sparking intense interest about the existence of life beyond our planet. The telescope's attention was directed toward Proxima Centauri b, the nearest known exoplanet to Earth. There, it discovered unusual atmospheric patterns, raising questions about what might be causing these signs and whether they could suggest the presence of extraterrestrial life. For decades, scientists and humanity at large have been eager to find any trace of life beyond our solar system. Any evidence that could validate the existence of life in outer space has consistently been met with enthusiasm. The recent detection of intriguing atmospheric chemistry by the James Webb Space Telescope marks one of the most significant moments in that ongoing search. While surveying deep space and transmitting crucial data back to Earth, the telescope identified these abnormal chemical markers coming from Proxima Centauri, but indicators of potential biological activity. These atmospheric signals hint at complex chemical interactions that could suggest a habitable environment. The scientific community has been astonished by the discovery, as it may represent the very evidence they've been anticipating for years. If confirmed, it would suggest that habitable conditions may exist outside our known realm, and only now are we beginning to detect them. The signals observed from this planet, located 4.24 light-years away, have prompted engineers at NASA to wonder how long these signs have lingered in space, awaiting technology advanced enough to perceive them. David Kipping, an astronomer at Columbia University, commented on the complexity of studying Proxima Centauri b. He noted that this exoplanet, part of the closest star system to us, exhibits a unique heat distribution unlike typical rocky planets. Usually, rocky planets absorb sunlight and emit infrared radiation uniformly. However, Proxima b displays an unusual infrared behavior that contrasts with its host star, Proxima Centauri. This difference made it an excellent target for observation using the James Webb Space Telescope, which excels at detecting infrared wavelengths. The telescope's infrared imaging technology is critical in deciphering the atmospheric secrets of Proxima b. Scientists plan to use this capability to study the planet's environment in detail, examining its thermal emissions to gather data on its atmospheric composition. Notably, the JWST's ability to detect the faintest rays of light in the vast darkness of space makes it ideal for analyzing the planet's night side, where evidence of biosignatures may also exist. The telescope can capture light within frequency bands 1,000 times narrower than starlight, making it highly effective at sensing even the most delicate natural illumination. Proxima b exhibits a dynamic relationship between its surface features and its star's radiation. The exoplanet's daytime side reflects radiant energy from its star, while the edge of its atmosphere reflects incoming light. The planet experiences a day-night cycle similar to Earth's, with temperature variations driven by its physical makeup. If the planet lacks an atmosphere, the temperature differences between its day and night sides would be extreme scorching during the day and freezing at night. This contrast offers valuable clues about whether Proxima b has an atmosphere capable of sustaining life. The JWST's precise infrared technology enables it to study these temperature fluctuations in detail, helping scientists determine whether Proxima b has the necessary atmospheric components to support life. The telescope's orbit also conveniently aligns with Proxima b's orbital period, allowing it to observe the planet's entire day-night cycle within just over 11 Earth days. Now that there's evidence of an atmosphere, researchers aim to analyze its chemical makeup to assess its habitability. Key indicators of life such as oxygen, water vapor, and methane are primary targets. Detecting these gases could imply that Proxima b has life-supporting conditions. To find these molecules, scientists must carefully study how light passes through the planet's atmosphere, a highly complex and precise process. Though the JWST is capable of identifying variations in water vapor, methane, and carbon dioxide, it has limitations when it comes to detecting bonded oxygen, one of the strongest signs of biological activity. Despite these limitations, a telescope can search for other important markers such as ozone, which can indicate the presence of a stable atmosphere. It's important to note, however, that the JWST is not omnipotent. It can only examine a few nearby exoplanets due to its design and range. For more extensive atmospheric investigations, scientists are turning to next-generation ground-based observatories like the extremely large telescope ELT, which is expected to begin operations in 2028. This telescope will offer deeper insights into the atmospheres of more distant exoplanets, adding to our understanding of their potential to support life. Until these future instruments are operational, the JWST remains a key resource in humanity's search for extraterrestrial environments. Even with its current constraints, the telescope continues to offer profound insights that are reshaping how we explore and understand distant worlds. The goal of upcoming telescope designs is to block out the overwhelming light from a planet's host star, using either internal masks or massive, space-based structures to isolate the faint light reflected by the planet itself. This is similar to shading your eyes from the sun to get a clearer view. Such developments will allow for more precise atmospheric studies of exoplanets. But distinguishing between biologically and geologically produced gases will still pose a challenge. Scientists must learn to differentiate life-related gases from those generated by natural planetary processes like volcanic eruptions. Despite these difficulties, researchers remain determined to deepen their understanding of exoplanets and to refine methods for detecting unmistakable signs of life. The James Webb Space Telescope provides a window into the future of space exploration. It's already revealing stunning insights, such as the discovery of far more mass in the universe than previously believed, mass hidden within enormous galaxies. These findings challenge established theories about the early formation of the universe. Over time, researchers expect the JWST to uncover more details about isolated planets and distant cosmic phenomena, enabling them to unravel the secrets of the universe. 2 decades ago, exoplanets were a novelty. Since then, astronomers have identified over 4,000 exoplanets orbiting distant stars, a testament to the progress of human ingenuity. Even so, NASA views this as only a small glimpse into the broader cosmic landscape. Scientists believe that trillions of undiscovered exoplanets may exist throughout the universe. Despite the absence of confirmed extraterrestrial life, the search continues with renewed hope and advanced tools. Past missions have offered fleeting hope. For example, when the Galileo spacecraft journeyed to Jupiter, it inadvertently recorded a spectral signature now believed to be a bioindicator, what scientists refer to as the vegetation red edge VRE. This signature, associated with extraterrestrial plant life, is identified through the way surfaces reflect light. The VRE provides a unique method of searching for alien life. By focusing on the light reflection properties of a planet's surface, using tools like the JWST, researchers now expect to uncover more about alien environments by mapping the orbits and characteristics of planets with inhabitable zones. Once identified, these parameters combined with VRE detection can offer compelling evidence in the search for intelligent life beyond Earth. When sunlight filters through a planet's atmosphere, the absorption of different wavelengths by atmospheric molecules creates a spectral pattern, much like a fingerprint that can be analyzed through spectroscopy. It is commonly theorized that as light from a star enters a planet's atmosphere, telescopes like JWST can detect and interpret the resulting spectral fingerprints. Earth-sized planets with atmospheres rich in nitrogen, oxygen, or carbon dioxide may be candidates for life. However, the absence of expected compounds or the presence of unusual ones could hint at unfamiliar biological systems or even technological civilizations. Some scientists argue that man-made molecules like chlorofluorocarbons, CFCs, used in industrial processes, could be definitive evidence of intelligent life. If the JWST were to detect such synthetic compounds in the atmosphere of a distant planet, it would represent indisputable proof of alien civilizations. This possibility opens a new chapter in the study of distant worlds and the search for life beyond the Milky Way. the concept of life beyond Earth carries endless possibilities. And as long as those possibilities remain, scientists will continue pushing the boundaries of our understanding in search of that elusive truth.